Hi, this is Mike from Sierra Sound. Today I'm making a video about anti-skate. I've been putting this off for a while because the topic is kind of misunderstood, a little bit contentious, and a little bit complex. But what prompted me to go ahead and get this done was there was recently an article done in Stereophile by Michael Trey, in which he wrote about the ViV Lab Rigid Float tonearm, which is a product that I distribute in the USA. And I was reading some of the comments on the article, which was a great article, by the way. It's highly technical. I really encourage you guys to read it. It's very positive, and I love the tone arm. And I want as many people to understand why I love this tone arm as much as I do. However, the comments, were reflective of a lot of doubt, a lot of kind of argumentative misunderstandings. So I wanted to make this video to kind of clear up as many misconceptions about anti-skate as possible. So I am biased. I am the distributor of this arm, but I really do love it, as does everyone who hears it. Still, there are a lot of skeptics on the internet. They're not shy about casting their doubts because this tone arm uses an unconventional alignment geometry in which there is no overhang, no offset angle, and no anti-skate. I'm not going to try to convert anyone or argue that this is the best way to design a tone arm. I believe that there are lots of great ways to design a tone arm. Each has pros and cons. But I do want to share my own understanding of how skating force works, how I arrived at this understanding, and how it applies to tone arm design. In order to keep this video from being a half an hour long, I'll get right to the point and show you what skating force looks like. When a record rotates, it's essentially moving in all directions. The top of the record's moving right, the bottom's moving left, the sides are moving up or down respectively. So when you place a fixed point of friction that is tethered to a pivot, in this case I tied a bolt to a string, and you will see that the point of friction gets pulled in a different direction depending on where it's placed on the rotating disc. And if you hold it at just the right spot, it will remain in place. Moving it forward causes it to slide or skate inwards, while pulling it back causes it to skate outwards. And also, this is critical, the further forward or back from the 0 point that it's placed, the faster and stronger the force pulling it in. Conversely, if it's placed slightly above or below, the force is very gentle. Replace the bolt and string with a stylus and a tone arm, and you can see that the same behavior occurs when playing records. On a conventional turntable like this Technics, we have a standard 9-inch radial tone arm with a gimbaled bearing and a spring-loaded anti-skate mechanism. A tone arm like this uses traditional alignment geometry, such as Beerwald or Stevenson, in which overhang and offset angle are introduced to reduce the amount of tracking error that the stylus encounters as it travels across the record. This means that the point of friction is placed beyond that 0 point that we discussed earlier, and that without a groove wall to hold it in place, the arm will skate inwards. Because this arm is at a fixed distance from the platter, there is no changing that, nor should there be. This is part of the design, as is the spring-driven anti-skate mechanism, whose job it is to counteract this skating force. As you can see, when we turn up the anti-skate, it's strong enough to overpower the skating force and can actually pull back toward the outer edge. With a specific amount of anti-skate applied, the arm can settle into a single spot without skating. However, let's see what happens when we introduce some friction. This is an old shellac record from the early 20th century, pressed only on one side, so the back is very hard and very smooth. If I tape a piece of paper to the surface, now the stylus will encounter some periodic resistance as it tracks. What you will see is that the friction does affect the skating force, and that the anti-skate force must be adjusted accordingly. You may be saying, so what? Well, the issue here is that on a record, the groove modulation is changing with the music, which means the amount of friction that the stylus encounters is constantly in flux, which affects the amount of inward skating. So no matter how carefully you set anti-skate, the amount of force being applied is always going to be too high or too low at any given moment. This creates a lateral shaking or instability of the cartridge between the groove walls, And this is the inherent compromise of an overhang design. Now check out the ViV Lab tonearm. I have it set up on this AMG Giro. I'm using the same disc as I did before. It's aligned using a single null point geometry, which can also be referred to as underhung geometry. There is no overhang, there is no offset. The single null point that we're aiming for here is the same sweet spot we talked about earlier, in which there was no lateral skating force inward or outward. The skating force is exactly 0 at this point. People in the comments may point out that because this is still tracing an arc, points on the record do still have some force pushing them towards the null point. But as the bolt on a string demonstrated, the closer to this null point, which is also the tangency point of the groove, the gentler the movement. So essentially along this arc, the skating force is either at 0 or very close to it. And compared with a tonearm that has an intentional overhang of 16, 17 millimeters or more, the skating force here is way, way smaller, and no anti-skate is needed. Now we introduce some friction to this setup in the same way we did before, and we will see that there's no change to the lateral movement of the arm as it goes over a rough surface. This lack of side-to-side shaking is why zero offset geometry is a valid alternative to more traditional designs. So people in the comments of the article I mentioned have also brought up a previous article that was done by Michael Fremer, in which he and the Wally engineering guys showed through a series of videos about how something pretty similar to what I showed here. They were basically proving that offset angle does not cause skating, and they did this by, really violently changing the offset angle of a cartridge and showing that no matter what, it skates in. And some people thought maybe, oh, that's because it's a radial arm. No, it's because it's an overhung arm. So I don't think anyone was actually making the argument that offset angle caused skating force, and if they were pretty far off the mark. And what I think that those series of videos that they made didn't show us is what actually does cause skating force. It was a little unclear what conclusion they were drawing from these videos. So I wanted to kind of try to fill in the blanks there. And what I hoped I pointed out here today is what actually does cause skating force, which is overhang. It's placing the point of friction beyond the tangent of the groove. Overhang does not, offset angle does not cause skating force. They were correct. Overhang does cause skating force, and overhang requires offset. So they are related to one another, although it's not a direct cause and effect. Also, as the distributor of the ViV Lab tonearm, yes, I am biased. I do want you to buy this tonearm because it's what I sell. It's my job to convince you that this is a great product. I really, truly do believe that this is a beautiful product. It's brilliantly engineered, it's meticulously designed, and it sounds fantastic. So if you can cast some doubts aside about this one element, which is maybe not as controversial as you may think, give it a chance. You may really, really, really love it. However, I also want to point out I'm also the distributor for AMG turntables, and they have their own line of tonearms which use traditional geometry, overhang, anti-skate. Although they use a magnetic anti-skate, which is much more gentle than what the spring anti-skate I showed you on the Techniques does. So these are also beautifully made tonearms that sound incredible. I've heard both of these types of tonearms make beautiful, moving musical presentations. So I can't choose which one I like better. I love them both. There are also a lot of other tonearm designs out there that are completely different from these two. There are linear tracking tonearms, which have their own sets of pros and cons. There are arms with pivoting head shells that completely try to eliminate tracking error by introducing multiple pivot points. There are unipivots, damped and undamped. So you could make arguments up and down all day long about why one design is superior to the other. The fact is there's a lot of different ways to design a great sounding tonearm, and they're all equally valid, and the proof is in the pudding. these, as Mike concluded, this is a beautiful sounding tone arm. So I'd say let me know what you think in the comments. Please be civil. I'm happy to continue to, answer any questions or correct any missteps that I made along the way. But remember, I'm a human being. I make mistakes. I may be wrong about some things, but for the most part, I think what I illustrated here today is pretty basic science. And then after that, get off the computer and let's go listen to some records, because that's really what this should all be about. So thanks for watching, and read that article. Appreciate it. Bye.